Hey everyone, my name is Sivas. Today I will walk you through my solution for Atlan release management problem. So as per the scenario, we have two major problems. Let's understand them and solve them one by one. So the first problem is that the current Helm charts is over 100,000 lines, which makes deployment slower, maintenance difficult, and scalability inefficient. To solve this, I propose breaking it down into microservice specific charts. Instead of one huge hill chart, we would have an umbrella chart with service specific charts. This would ensure modularity, faster deployment time. So we do not have to redeploy the whole project if only some part or some service is changed. So let's see how can we implement this. So we would use the inbuilt dependency functions and methods to implement a hierarchical structure. So we would define the definitions of dependencies in chart.yaml, and we can either use local charts or external charts, which we can define in charts folder. So we can also use Helm operator for declarative release management. So we do not have to run commands again and again so to deploy the updates. We would also implement a differential deployment strategy to only to only sync components which are changed, and we will deploy parallelly to make it faster. So the solution has some trade-offs and some problems which are acceptable. So the first one being the higher initial effort. So to decompose the chart is a very challenging task. We have to keep in mind certain configurations. So, and we have to keep that there are no inconsistencies between specific subservices. So that's the very hard task. But the long-term investments and the long-term benefits are the faster deployments and maintainability, which are worth. The second problem was that the current testing mechanism is not so great, so that the tests are boring to write and there are flaky tests. So I propose implementing a comprehensive testing framework. It will have two main features. The first is intelligent test selection. So what I mean by that is if suppose a developer change particular component, so the intelligent test selection mechanism will select tests which are affected by the change. Only the tests which are affected by the change, not the whole test, all the tests of the service combined, only the specific tests. And the second feature is parallel execution, which would make running tests a lot faster. We can implement it by only running tests affected by code changes via a dependency analysis method. We would use dependency analysis to find tests which are affected by the change and run only those. We would also run tests in a containerized environment, which we can easily manage and retry flaky tests. And we would improve developer experience with visual reporting, which would make debugging a lot easier. So it also has some trade-offs like the previous one. The first is the initial investment. So as I mentioned earlier, the parallel execution part. So parallel execution require more computing power. So it means higher cost. The cost will be improved little, but cost scaling mechanism can optimize cost methods in cloud platforms like AWS, Azure, and GCP. But the long-term benefits that are faster and more reliable deployments and false negative, that's the biggest thing. The tests are reliable, so it would work. There are some known gaps in my solutions. The first is the initial migration complexity, like the one-time effort to transition from monolithic to microservice charts is a very big task, but it is acceptable due to the long-term benefits. The second is that if there is any inconsistencies between anything across service chart, it would be a disaster. So we would have to maintain templates, linting, and governance audits to make sure there are no inconsistencies. The third is the resource utilization, like parallel execution needs a higher compute. have higher compute needs. So, but it is justified by the time it saves to run the test, and also cloud scaling can optimize the costs. The fourth is the learning curve. The developers have to adapt to the new workflows, but it can be mitigated using proper documentation, training, and templates. So, in conclusion, these were my two solutions which can help counter the problems currently there. So, I have designed a high-level system design. So let me explain it. So the first step is the CI/CD pipeline in which the developer pushes the change or the code. As the developer pushes the change in the GitHub repository, Jerkins and GitHub Actions picks it up. They first runs these tests. Unit test validates the individual component. Integration tests validates the dependencies or like if they are working with integration with other components, like this test is working but other test it is dependent on other tests so that they both are integrated well and are working. E2E test simulates and the user experience. So Jerkins or GitHub actions whichever we like, they will pick up the code, run the tests, and then they will pass it to AgroCD. And I have two major components here as testing framework too. These are to optimize test. So first is test caging. So we would reuse the test results wherever we applicate to optimize the test. And the test data builder is used for dynamically building data sets for tests. And here in the Helm chart management, this was the original Helm chart, which is a monolithic Helm chart. I have break down it into microservices chart, which is from 1 to n, and however how many we have. They all are connected by Helm operator, which would help and ease the version rollouts and any problem if we face, we can just roll out from Helm operator. So Agro CD, after the changes and all that, will pick up the deployment and will deploy it to the K8s cluster. So it would be done. But now comes the main two parts of the deployment, the canary deployment and the feature flag service. Canary deployment we have implemented to roll out features gradually as to mitigate the risk, like a certain production level change made a bug. So if we use canary deployment, the bug will only be affecting only some people for which the feature has been rolled out. So we would only roll out feature gradually. The feature flag service will help us to toggle features without redeploying. Like we can just toggle this feature enable and disable without the whole need of deploying the project again and again. So, and this is the Prometheus and Grafana, which will be used for monitoring the services. So we can monitor the resource consumed by the product and all that. So this is the high level system design I have built. So now comes the part, the challenges which I faced uh, while proposing and by thinking the solution. So the biggest challenge was that I was thinking myself as a imposter. Like I thought I would wonder if my proposition was too basic. Like in comparison to the experienced engineers, I'm just uh, a student as of now. So, but I remembered that small changes can also make a big difference. But I think they are some good changes, but I'm not really sure. I just have used the best practices available. So the second main challenges was that I was nervous about shooting this video as I'm a little bit camera shy, but I solved this problem by preparing a script and improvising it again and again has to make my confidence and release my fear of camera. So this is the my assessment solution. Thank you very much.